We'll round out our discussion on the types of reactions by moving from redox reactions now to metathesis reactions. So let's start off with a definition of what a metathesis reaction is. And this is a chemical reaction where two compounds are going to react with one another, and they're going to interchange and form two new compounds. So we have two compounds reacting to form two new compounds. This will involve our positive and negative ions switching places. So I tend to like to think about our positive cation switching places to form new compounds with the new negative ions. These are also called double replacement reactions. I prefer the term double replacement, that one's stuck. You might hear them called double displacement, double substitution, or simply just metathesis reactions. Let's go back and review our types of reactions. So all reactions for us are falling into two categories. You have your redox reactions, your combination, decomposition, single replacement, combustion. That was another podcast that involved the exchange of electrons. And then we have our metathesis reactions. And these include two reactions. We'll focus more heavily on double replacement reactions during this unit, but neutralization reactions, which we'll mention, are also a type of metathesis reaction, and we'll see more neutralization reactions when we cover acids and bases. All right, so let's get into an example that shows double replacement reactions. So we're going to start off with two compounds. So these are our two compounds, AX and BY, and they're going to react with each other. And the way I like to think about it is A and B represent my metals and X and Y are representing my nonmetals. So I like to think, instead of switching everything around, it's confusing to me. I like to think of A and B, because those have the potential to form cations. I like to think of those as switching places. So A is now paired with Y and B is now paired with X. And so, oh, look at this, our cheat sheet is back. Don't forget to add in there our double replacement reaction. This is a type of reaction, even though we've put them into two separate podcasts, it is still a type of reaction that you're responsible for. When we form these two new compounds, we have to be sure to look at the charges and drop and swap to get the correct subscript to form a neutral compound. So here in our example, we have, and of course the letters are different because I'm not about to make my own art. We have A and B together in C and D. And A and B A and C, excuse me, represent our metals or our cations. So we're going to have those flip-flop places. So the bond between A and B will break and the bond between C and D will break. And we'll form a new bond between A and D and C and B. Okay, so that's essentially your double replacement. You're replacing both. In this example, up here, barium chloride and sodium sulfates are going to go through a double replacement reaction. And I'm going to swap my barium and my sodium to get two new compounds. So just to show you what's going on behind the scenes, barium has a +2 charge. Okay, it is now going to be with sulfate with a 2- charge. So since these charges are opposite but equal, they're in a 1-to-1 ratio. I don't need any subscript here. So my new compound is BaSO4. And I'm going to double check my charges with my cation with my new anion just to make sure. Sodium is now going to be with chlorine. Chlorine has a -1 charge, sodium has a +1. Opposite but equal, there is no subscript necessary. Okay, and my final step will be to balance the reaction. Okay, so our final type of reaction is a neutralization reaction. Again, we're bringing this up because it's a type of metathesis reaction, but it's something that we're not going to really dive into as much now as we will in our acids and bases section, but it really functions the same way as a double replacement reaction, but there are a couple things that make it unique. So we will start with an acid. So this is my acid and this is my base, and those will react to form water and a salt. So we use the word salt in kind of a vague sense. Salt is going to refer to any basically soluble ionic compound. So here we have a metal and a nonmetal. It's an ionic compound, a transfer of electrons. That's my salt. Just to show you that this will function in the same way as a double replacement, let's write out what's going on. So just in case I don't recognize this as being an acid and a base, that I think, oh my gosh, it's two compounds, this must be a double replacement reaction, because that's what we have here. You can manipulate your cations the exact same way and come up with the same answer. Let me show you. So here, hydrogen is a cation, it has a +1 charge, and sodium is a cation, it has a +1 charge. So we're going to swap places with these. Okay, so now my sodium with a +1 charge is now with chlorine with a -1 charge. Those charges are opposite but equal, so I don't need any subscript. So NaCl is my salt. Hydrogen with a +1 charge is now with a hydroxide with a -1 charge. Okay, these are opposite but equal, so I don't need them. However, nobody writes this like this. Instead, they use subscripts to say this is 2 H's and 1 oxygen, or forming water. So as long as you know that this functions the same way as a double replacement, you should be good to go. But if you do happen to see one of the products being water, most likely you are dealing with a neutralization metathesis reaction. Okie dokie, let's try putting this all together and let's predict products of metathesis reactions. So I kind of gave it away. You know this is either going to be a double replacement or a neutralization reaction. Let's pretend I didn't say anything. Here are those steps that we used in the last podcast. I'm going to try my best to actually use them. We're going to write out neutral formulas for the reactants first. So sodium sulfide, that's sodium with a +1 charge, and sulfide with a 2-. When I drop and swap, that should be Na2 and only 1 sulfur. Okay, reacts with means plus. Barium nitrate, that's Ba with a 2+ charge. Nitrate is NO3 with a -1 charge. So when I drop and swap, I'm going to actually need to add parentheses and put that 2 as a subscript outside of that, because I don't want it to look like I have 32 oxygens, because that's insane. So now I have 2 neutral compounds. My next job is to come to my list and figure out which of these have 2 compounds to start. It's not combination, it's not decomposition, that only has 1. It's not single replacement because I don't have a single element and a compound. Okay, we are between double replacement or neutralization. And remember, your trick here is if you treat them both like a double replacement and you swap your cations, you will be able to correctly predict products for neutralization as well. You won't be able to identify the right type, but it'll get you far. Okay, so this is definitely double replacement, so I'm going to treat this as a double replacement. I'm going to swap my 2 cations. So sodium with a +1 charge is now with nitrate with a 1- charge. Those are opposite but equal, no subscript are needed. Barium with a 2+ charge is now with sulfur with a 2- charge. Again, opposite but equal, so we only need them in a 1-to-1 ratio. I don't need any subscript. Awesome. Oh gosh, I forgot to check off my steps again. Oh no! I wrote out the neutral formulas. I identified the type of reaction. I at least narrowed it to double replacement neutralization. I predicted products based off of rules. I wrote neutral compounds. I am here. I am ready to balance, which is always the final step. 2 sodiums. I can make this 2 and have 2 sodiums. 1 sulfur here, 1 sulfur here, 1 barium, 1 barium, 2 nitrates, and I have 2 nitrates here. So we're balanced. Now, at the very end, I can look and see, did I form water as one of my products? If so, it's a neutralization reaction. I did not produce a water. So this is a double replacement reaction.